So this here is a cutaway model of the two exterior walls, an eave wall and a gable wall, so where the eave wall and gable wall meet, of one of our integrated truss houses. And I just want to take a little time in this video to discuss some of the construction details as they would relate to the guys that are building these structures, particularly the foreman and the superintendent. First and foremost, for anyone that hasn't built one of these before, all the same framing and layout applies as you would for rolling a truss roof, except now obviously we have the walls and the floor in there, and instead of a truss that may be 6 feet tall at the peak, the entire structure could be as tall as 16 feet plus another 4 feet off the ground. So what that means is all of a sudden you've got a truss that's 16 feet tall and way up there in the air, so the bracing gets even more critical. And that's especially holds true if you're building in western Alaska or any place where you might have wind. If this structure sits overnight and isn't adequately braced and sheathed, it gets to be pretty treacherous. If wind comes along, it could knock things over. I'd also say that for safety reasons, we want to make sure that as the trusses are being rolled that they're adequately braced. Because of their height, the amount of moment that can be introduced as people are climbing around in the trusses and moving around can be enough that things can tip over as well. So first and foremost, I want to say keep it safe. Some of the tools that we use with the bracing, usually in every materials package, we'll have some variation of a 4-inch structural screw. And what those allow us to do is to provide a very positive attachment for any temporary diagonal bracing, horizontal bracing that needs to go inside the trusses. The screws hold a lot better than 16-penny nails, especially if you attach them, the bracing goes in a V pattern and so forth. Some other things that we've learned with building these big structures, these big trusses, is when you get a floor that's 30 feet wide, sometimes there's irregularities simply because your floor cord isn't straight, and so we will put in a lot of temporary bracing rat runs on layout so that our floor is nice and straight when we start putting the subfloor down. This also applies to the roof, and in every material package we try to include at least 4 runs worth of Simpson truss bracing. This stuff is nice because it'll fit right over 2 trusses, keep things on layout, and so the guys working in the rafters can safely put this on where it might be a little harder to put on 1x4s or 2x4s as lateral bracing, and it keeps everything on layout. So check the materials lists. This is a tool that will help things out. In addition to temporary bracing, we also have permanent bracing, and we'll take a closer look here. I'll point out where the permanent bracing is. You can see here we've got a floor truss that's 28 inches deep. It obviously is cut away here. So in every truss bay, we've got a sheet of 1 1/8" plywood. This keeps the truss from rolling over, and because there's a section of panel at the floor and a section of panel at the roof, what we are doing is taking all of the shear and the racking loads and bringing those down to the beams by putting these panels in here. What we've done is we've sized these panels so that if you cut a sheet of 1 1/8" plywood in half, you can get a top panel and a bottom panel. So before you start cutting, check your layout and your heights, but it should work out that you can maximize use of your materials simply by cutting the sheets in half and using the pieces top and bottom. These don't have to fit tight. Typically, we have, for example, here a 22.5-inch stud bay. We'll cut the panels at 22.25. By the time you add nail plates to the trusses and you get irregularities in the trusses, a 22.5-inch panel is likely to bind up, and you'll start gaining on your wall widths as you start rolling out trusses. So go with a 22.25-inch panel and just check your layout to make sure that the truss layout isn't gaining as you go along. The structural sheets in the plans We'll have the fastening schedule for these panels. I will say, just like a normal truss roof has lateral bracing, these panels also require a shear brace. It's just a 2x4 that runs the full length of the roof. You can see it here, continuous 2x4 shear brace. There's going to be one of these at the top panels and one of these down here at the bottom panels. These can be fastened from the back side, typically with 4 8-penny nails. That information is also in the structural sheets. A word of warning, on the top lateral brace here, there may not be enough room between the bottom chord of the roof truss and the underside of the top chord that this panel or this brace this 2x4 can be installed flat like this. You may need to rotate it 90 degrees. That's okay as long as you can get your 4 nails in through the backside. It's okay if they go into the edge. You would end up nailing into this 2x4 or this 2x6 and nailing into the edge of this brace. I guess just to reiterate, bracing is everything when it comes to building an integrated truss house, especially during the framing stages. And you want to check the plans and then just make sure that all the bracing and nailing schedules have been met. One other thing I'd like to point out, the beauty of this integrated truss design is you can get the building shell up really fast and get a roof on it. But what happens is, if you're staging plywood, say you're using a squirt boom or something and you can take a full unit of 5/8 CDX roof sheathing, you don't want to set that all in one place. The odds of point loading 3 or 4 trusses with a tremendous amount of weight are great enough that we have a concern that the roof could fail. So we would advise not putting units of plywood onto the roof, but rather sending the plywood up in individual sheets or staging it in smaller groups of 3 or 4. Don't put the full unit of plywood on just a few trusses and then plan on pulling it off of there. That is a safety concern. Once the roof is sheathed, everything gets a lot stiffer. Once the walls get sheathed, it gets even better, and the floor. And once it's completely sheathed, you've got a tremendously strong structure. We've designed these buildings to resist 165 mile-an-hour wind loads.